Hello and welcome to the second part of Lesson 1-1. Today we're still looking at variables and expressions. Now back in the part 1 video we talked about expressions, and if you remember, a numerical expression was a mathematical phrase that only used numbers and operation symbols, something like 3 plus 5, 4 plus 6, 10 minus 9, something like that. We also looked at variable expressions, which were mathematical phrases that used variables, numbers, and operations all together. So you might have like 3x minus 1, 2x, 5 plus n, something like that. Those are variable expressions. Today we're going to look at equations. So the difference between an equation and an expression would be something like this. So 5n, we'll say plus 1. This right here, this is an expression, just like what we talked about in the part 1 video. At the point that I go in and I write the equals sign, and I set it equal to, let's say, we'll say 21. Okay, so once I go in and I draw in that equal sign right here, this now means that I have an equation. Okay, so this whole thing then is an equation once I drop in that equal sign. So an expression is 5n plus 1. An equation then is going to be 5n plus 1 equals 21. So let's go ahead and look at a few examples. For example 9, it says Track One Media sells CDs for $12 each. Which equation best represents the cost, C, of a given number of n CDs? So here we're trying to find the cost. So our cost is equal to, now when you're trying to find the cost of an item, and if you're buying more than one item, you're going to take your price and you're going to multiply it by the number, and in this case we have the number n CDs. So my cost is going to equal 12 times n, which is the number of CDs, and that again will equal the cost. So this right here is my equation. For the second part, it says, suppose the manager at Track One Media raises the price of each CD to $15. Write an equation to find the cost of n CDs. So again, our cost is going to equal the price of the CD times the number that we purchase. So this is part A. Part B now says, suppose the manager at Track One Media uses the equation C equals 10.99n. What could this mean? So based on what we did in part A, we know that our cost is going to equal our price times the number of CDs. So 10.99 tells us that this is the price of one CD. So it looks like they were running a sale. So now for example 10, it says we're going to define variables, which just means we get to pick the variable, and we're going to write an equation to model each situation. So for 17 here, it says the total cost is the number of cans times 70 cents. So the total cost tells me that I have C equals the number of cans times 70 cents. So you can write this as 0.70 times C, or you could have done C times 0.70, whichever your preference is. For number 18, it says the perimeter of a square equals, so perimeter of a square equals, so that gives me P equals 4 times the length of a side. So I'm going to go 4 times L, which would be the length of the side. For number 19, we have the total length of rope in feet used to put up tents is, so total length, so I'm going to come down here and I'm going to say length is 60 times the number of tents. So 60 times the number of tents, and I'm going to call the number of tents T. And then our last part to this example says, what is the number of slices of pizza? Now, I personally don't like to use the variable S because sometimes it looks like a 5. So I'm going to put P for pizza. So it says, what is the number of slices of pizza left from an 8-slice pizza after you have eaten some slices? So in this case, we know that we're starting out with 8 slices, and for every piece that you eat, we're taking them away. Now, because we don't know how many pieces are being eaten, we're going to put, I don't know, let's say 8 minus x, and x will be the number of pieces that are consumed. So I have the number of pizza slices is P equals 8 minus x. For example 11, it says write an equation from the data in the table. So this is going to look a little different. And I don't know if you guys have covered this or not, but typically in a table, if you're given a 2-column table like this, we call this column our x variables, this column our y variables, and our x variables are what we call the independent variables, meaning that we can change those. Like these right here are going to be the values that we choose to put in. Okay, then your y values are going to be called the dependent values, and that's because these numbers here are going to be dependent upon what you plug in for your x value. So when you're given a table like this, typically the table is going to be in some form of y equals something. So when I go to set up my equation, I know that my equation is really going to be my y stuff, which my y variables or values we set is the change from a 20. So I'm going to put change from a 20 is equal to, and if we look at our x values, it looks like we're starting out with $20 and we're subtracting the cost of our purchase. So in this case, the cost of our purchase, let's just write that as x. So now if I want to simplify this down, I can say C for change is going to equal $20, because that's what I'm starting with, minus the cost of my purchase, which in this case we set as x. So this right here is my equation then. And now one nice thing that you can do is you can always pick a couple points and make sure it makes sense. So what I'm going to do is I'm going to say if I start out with a $20 bill, and let's just pick this number right here. Let's say I want to go ahead and I purchased something that's $17.50. So I'm going to take $20 and subtract $17.50, and I need to confirm that that gives me this value here, which would be $2.50. And 20 minus $17.50 is actually going to be $2.50. So I can say that this does double check. Please take a quick second, pause the video, and try this on your own. So now that you've had a chance to try it, example 12 again is telling us that we have to define the variable and write an equation. So this time it looks like we are looking at the number of radios built, because remember, this is my x, this is my y. So I'm going to say the number of radios built is equal to, and it looks like we're looking at the number of workers. So when I look at this, and I'm just looking at this first scenario here, it looks like if I have one worker, that worker can build 13 radios. When I go up to 2 workers, I get 26. So it looks like I get 13 radios per worker. So the number of radios built is going to be 13 radios times the number of people that I have working. So I'm just going to put N. So here, I'm going to put R for radio equals 13 times the number of people that are working, and now I have my equation. Again, let's just do a quick double check and make sure that it works. So I'm now going to pick this fourth spot down here. So if I take 13 and I multiply it by the number of workers as 4, 13 times 4 gives me 52, and if you notice, that's what I had right here. So I'm going to say that I'm probably on the right track. So this here is going to conclude the part 2 video for lesson 1-1. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.